Today, we were going to overview this device fabrication process. First, a wafer. As wafer gets bigger, then we can make more chip or die per a one wafer. However, in 450 millimeter wafer, it is hard to process to fabric. It is hard to fabricate the chips, so we don't use today. We use a 300 millimeter wafer. And also a scaling down is a key for device fabrication because there is four driving forces for a scaling down. First, a power. In CMOS, there is a dynamic power dissipation, and the key factor of the power is capacitance and operating frequency. And so we need to make lower total capacitance. And second, there is performance. Performance is the related to the time constant tau equals RC. So as lower resistance and capacitance makes higher operating clock. And third, area. As we make smaller chips, then we can make more chip on the one wafer. And finally, a cost. The yield, as we make smaller chips, then we can get better yield. And as late 1990s, we used to scale down the gate lengths. However, we make, because of the short channel effect, or else, we had buffer, or we have hard time to scaling down. So engineers try to the modern engineers use strain engineering to make a modulate the EK diagram to make lower effective mass. However, it had a break. So nowadays we use a 3D structure. And making a chip, we use a layout. We first make the active layer, which is a body. And after that, we make this gate layer. And lastly, we make this contact metal or metallization. So now there is a very important process in device fabrications, which means a lithography. The lithography means that engraving the patterns like circuit design in the wafer. So there is a fabrication process making a MOS. We first make the wafer and we deposit the oxide or this circuit protecting layer, which means we correlate this oxidations. And after that, we engrave the circuit design in the semiconductors. We call it the lithography and etching. After lithography and etching, we dope the dopant like N-type or P-types. After that, we deposit the polysilicon or metal. We call this a film deposition. After that, we make this gate. After that, we etch these edges and make the gate. And lastly, we dope and to prevent outer interventions, we deposit the silicon dioxide or like Finally, we make a metal contact like aluminum or metals. We call this process as metallization. After we make this chip, we test these chips. First, um, we see the electrical test by using swing, debug, or any other parameters. And after that, if we find these defect chips, we check up, and after that, we repair using a laser. After that, we package using resins or plastics. In etching process, we use this hydrofluoric acid. It is important to dealing with this acid. When we make a semiconductor chip, we make chip in clean room. In clean room, they are sustained with a positive pressures to prevent infiltrate of any other particles, and also we keep everything on the table, not the bottom, the floor. There is a class in clean room. The class 10 is 0.5 micron particles are there are 10.5 micron particles in 10 feet, 1 cubic feet space, and the class 1 is there is a 0.5 micron particles in there is 1.5 micron particles in 1 cubic feet space. To making this environment is hard, so nowadays we use a FOUP and force feed. The FOUP means that a front open unified pod. In this FOUP, in FOUP, there is sustained with a almost vacuum, and we clean it the nitrogen gas to prevent infiltrate of any other particles. So using this FOUP, we can sustain the environment in clean room or less higher class. So we can save investments. And before we go into clean room, we need these protection gears like safety glasses and caps, gloves. We cover every part except for my eye with these clean room gears. And the lithography, photolithography. Before we engrave these patterns or selective patterns in the wafer, we coat with the photoresist. The photoresist means that it resists the photons. So in coating, we use a spin coating, which uses a centripetal force to deposit evenly on the wafer. After that, we expose the light or electron beam. And there is two types of lithography. First, a positive. After we exposure the light, we develop the photoresist by in develop stage, we make weak bond on the exposed part. So make the patterns. In negative lithography, we cross link each other in photoresist to remove any other exposed part in develop stage. After that, we etch. We remove the wafer selectively in etch stage using our hydrofluoric acid. After that, we remove the photoresist. We call this stage as strip or lift off. And there is a photo mask or lattice, lenticle. Photo mask means that the blueprint for the making selective patterns. We make photo mask or lattice, lenticle using also lithography. So the full scale mask, the one-to-one scaled size, we call this a photo mask. We don't use nowadays because it is hard to make this nanometer scale gate or nanometer scale line. So nowadays we use this optical lens. So it is not one-to-one scale. There is a one or two or multiple die per a mask. So in reticles, we use a blank mask, which is crystal or quartz. And using a blank mask, we can use also photo mask or a use like in liquid crystal display, we can use it as a wafer for the thin film transistor. And after that, we have to align the patterns, or after one stage, we need to align these chips for every process. So we use a alignment key to align with each other process, because if there is a misalignment, then in transistors, gate will not deposit or develop straight. So it can result short or bad swing, or we should have to remove we cannot use the specific die if not aligned. And there is pellicles. The pellicles are protect film for the photo mask, which are prevent from any other particles by using the focus. If the particles on the pellicles, then if we exposure to the wafers, then the particles would get focused out from the wafer, so that the shape of particles would not engraved on the wafer. It is very important. So overall photolithography procedures is like here. We first clean the wafers and oxidate the wafer surface by deposit the silicon dioxide or something else. And then we spin coat the photoresist. It is liquid state, so we soft bake to remove the moisture in the photoresistors in low temperatures. After that, we align the mask and we exposure to pattern to wafers, and we develop photoresist positively or negatively. After that, we hard bake. The reason why we hard bake is different different with soft bake. In hard bake, we the reason we hard bake is that to use photoresist as a hard mask. So we make photoresist as thick, as harder. So after for after process like etching. In etching, we use normally wet etch, which uses hydrofluoric acid or something else. After that, we remove photoresist, the lift off or strip procedure.